Alright guys, hello, welcome back. All my previous videos was how to use visual. The previous videos was followed all this in a Visual Studio Code, where we saw everything, code labs, tutorials and everything. Today we're starting with development. So we're just starting with user interface, introduction to widgets. Flutter widgets are built using modern framework that takes inspiration from React. The central idea is that you build your UI out of widgets. Why widgets describe their view should look given their current configuration state. When the widgets are rebuilt, its description which framework against different. Okay. If you like to become better acquainted with Flutter by diving into subcode, check out Basic Layout Flutter Interactive. Do not click this because we may have wrote some code before, but this is to explain the basic how can I say, basic fundamentals of what these lines do. Alright, the minimal for of simple calls run app. Now you see void main is just a beginning suggestion, but the run app, the install inside the run app. So you want this ends here, you ends it with this constant center, alignment, child, text, hello world, text direction, run. It's supposed to show the result, but it's not showing it. There will be a small hello world. Yeah, there we go. It takes time. The run app function. The run app is the beginning. Okay, you simply write import the Flutter material, Flutter package.material, and write void main. This is like a complete beginning. Center consists of a two widget and makes it the root of widget tree. In this example, the widget tree consists of two widgets, the center widget and it's a child, the text widget. Wait, center is also a widget. It's considered a widget. It's not considered alignment, it's considered a widget. The framework forces the root widget to cover the screen, which means the text will end up at the center of the screen. The text direction needs to be specified. In this instance, when the material app widget is used, this is taken care of for you. As demonstrated later, when writing an app, you'll commonly author a new widget that are subclasses of either stateless widget or stateful widget, depending on whether your widget manages any state. A widget main job is to implement build function which describes it widget in terms of other lower level widgets. The framework builds those widgets in turn until the process starts out in a widget represent the underlying render object which computer and describe geometry of the widget. Alright, basically everything is widgets, which we have learned. Alright, basic widgets. Flutter comes with a set of powerful basic widgets which commonly use the text, raw column, that's it. Stack, instead of being linearly oriented horizontal stack, widget lets you plot out of each one. In paint order, you can use the precision widget on the children of the stack. Okay, this is something we haven't seen, but it's okay. Container widget lets you create a rectangular visual elements. Container can be decorated with a box decorations such as background, a border, or a shadow. Alright, let's see what they have done in the app bar, the top app bar with the title final widget. Wait, what? Why they declare final? Fields in widget subclass are always marked final. A widgets subclass, so this comes in the app bar. They put widget title, and this is considered a sub, so that means the top app bar will have these properties: box decoration, color blue, icon, navigation menu, expanded. Why did they expand it? No idea, but let's check it. They created another my scaffold, super key, override, widget build contexts, return material, column, example. Okay, constant expects, child, center, child. Now we're running it. Title, map, used by the host task switcher. Home, safe area, child, my scaffold. So we're simply header. This is body. Now let's see what it shows. If my guess is correct, there will be a home bar or the app bar in the top with the icons and stuff. And below there will be, yeah. Wait, there's supposed to be an icon here. Is it, oh, it's the search icon? Did they put the search icon? I noticed there was an icon. Yeah, it's a search icon. Yeah, that's what they put. A navigation bar is here. It's there, but it didn't say when you click navigation bar there will be a drop or something. Yeah, there we go. That's what it did. Tooltip, navigation menu. If you overhover it, this is the tooltip. Oh, did they put tooltip on search too? Yeah, they did. Wow. Okay, maybe I should pay more attention to each code. That's actually a nice home bar, home page. But they didn't make any code. What happens if you click this and what happens if you click this? So that is something maybe a little bit more advanced. Because if you click this, scroll down or something, if you click this, typeable bar or something, I guess that's something advanced or considered advanced maybe. Pages use material design to entry in Flutter section of your bubspec.yaml file. Okay, you have to enable this so that you can use material icons such as search and icons, tooltip, navigation menu. Oh, menu. Icon name is menu. Okay, that's you have to remember. And this icon is search. Many material design widgets needs to be inside a material properly in order to inherit the theme data. Therefore, run the application with a material app. The app bar widget creates a container with a height of 56. Device independent pixel with an internal padding of 8 pixels both on the left and right inside the container map. app uses a raw layout to organize its children. The middle children, the title widget, is marked as expanded, which means it allows to fill any remaining while space that has been. Okay, what this says is it means say like pixel 6 device pixel blah blah blah, but what it really says is it's expandable, it's auto compatible. Yeah, auto compatible is the right word. They may have mentioned too many stuffs. The thing is, these apps you make, they are auto compatible with any devices such as PCs, mobiles, Android apps, any. That's what they have trying to take. You can have multiple expanded children to determine the ratio which they consume the available space using flux argument to expand it. Did they use flux? See flux is expanded, but it's all right. It's simply called home safe area. Did they mention safe area? Oh, they expanded it so the app bar comes within here. Okay. Using material components. Flutter provides a number of widgets that help you build apps that flow material design. A material app starts with the material app widget, which builds a number of useful widgets at the root of your app, including a navigator which manages a stack. All right. Navigator there, which manages stack widgets identify string, routes the navigator transition smoothly between the scene of your application using a material app, which is entirely optional but a good practice. All right. Now let's see what they have done. Scaffold, app bar, navigation menu, on pressed null. This is also on pressed null. Hey, they didn't give it anything. Floating action button, constant floating, tooltip, add. Oh, they added this one. Okay. I thought they were gonna give something for the navigation menu, but they didn't. They just simply added a button. And they did it after floating action button used by assistive technology. We change this to help. Let's see what it does. This plus icon will change to help icon. Wait, what's the help icon? Does it look like someone talking a little bar or something? Ah, it's a question mark. Okay. If we change this to chat, it will be a, let's say, if you have any doubts, click here. Those kind of chat icon. The small little box with some letters, I guess. Yeah, see? Simple. And if you click this, a little window will pop up and you type the questions like frequently asked questions, or they may be able to send messages or something. See? Simple. Just by changing an icon, you change the function of this button. It may show null, but on press, reconnect to chat or something. Right now, notice this on pressed are kind of null, but this will give a very interactive function later. Maybe we are not at the interactive section, I guess. Maybe not now. But remember, floating action button. Okay, this comes in body. Actions. What is actions? Title is okay. Title constant text. What is this action then? Floating action button. Is it like describing? Leading. Okay, there's some code that not fully understandable, but just like how we understand the run app, these each individuals, we will understand what this means later. How this is determined and how this determine the outcome. We will look into it later. Okay. Now that the code has switched from my app or my scaffold, the app's starting to look into more material. For example, the app has a channel like the encrypted styling automatic floating button is also added. Notice the widgets are passed arguments to other widgets. Scaffold widget takes a number of different widgets as named arguments, each of which are placed in a scaffold layout put in up the appropriate place. Similarly, the app bar widgets lets you pass in widgets for the leading widget. Oh, now they have mentioned. Now they have mentioned it. Here's the little thing we didn't understand. They have mentioned it here. So let's read this carefully, so we will not get confused. Scaffold widgets takes a number of different widgets named arguments, each which are placed the scaffold layout in the appropriate place. Similarly, the app bar widgets lets you pass in widgets for the leading widgets. Oh shit, I clicked. There's an explanation, but let's do that. Leading widgets and the action of the title widget. This pattern recurs to framework and is something you might consider when designing your own widgets. Leading, actions, title. Now we have to look into this, so in order to understand what happened here. widget to display before the toolbar. Oh, this is literally what else you can put in app calls. What is this? API. Okay, let's remember this. The typical text contains a description of current title widget concerned to fit within the remain space between the toolbars, leading and actions widget. Its height is not constrained. The title is vertically centered. Damn, look at this. There's tons of stuff. Anyway, leading, title, actions. Now this is what this describes. Leading will always go to the first. The title will always be in the title. The actions goes to last. I'm not sure how this is determined. They also show the wait. The title. Okay. Now the navigation bar is the navigation bar is not here. But they what did they put as? Wait, what? No, that's not the one. Now let's test this a little by ourselves. See the actions, the leading, how they work. Now you see they have put this in leading, and they put the search icon in the actions. So we're gonna change this. We're gonna change actions to leading. And leading to actions. Wait, what? You can't assign it like that? Okay, apparently you can't. Handling gestures. Most applications include some form of user interactions with the system. The first step in building interactive application is to detect input gestures. See how that works by creating a simple button. They call this a simple button. Okay. Class my button, state plus widget, constant my button, super key, widget build context text return gesture detector. What's a gesture detector? On tap my button was tapped. Where? Oh, it's in the console. Okay. Child container height 50, constant edge install all 8. Let's change it to 16 to see how it does. This is the edge, I believe, but let's try. I don't really see that much difference, but maybe something may have happened, but it's alright. Border radius circle 5 colors light green. Gesture widget doesn't have a visual restraint, but instead detects the gesture made by user when user taps container. Gesture detects on tap callback printing message. Changing widgets in response to input. So far, this page has used only stateless widgets. Stateless widget receives argument from the parent widget, which they store in final member variable. When widget is asked to build, it uses the stored values to derive new arguments for the widget it creates in order to build more complex experience. For example, to react in a more interesting way, the input application typically carries some state. Flutter uses stateful widgets to capture this idea. Stateful widgets are special widgets that know how to generate state objects, which are used to hold state. Consider the example using elevated mentioned earlier. Elevated button. Class counter strip. This class is a configuration for a state. It holds the value in case provided by parent and be used to build a method of state. Fields in a widget subclass always mark the final. Okay, this is stateful widget. That means the whatever the values in the widget, it will not be passed or get them. Stateful widget. That's how it mentioned here. If there's a value, it will be inside it. If you're expanding it, you have to use subclass. Set states. Read this carefully because I kind of understand how this works. On press it increment and counts. This is simply a counter. I mean count. Increased number will increase. The number starts with 0, I guess. Yeah, int counter starts with 0. So you press. It goes 1, 2, 3, 4, 5. It's the input the value like 20 and it will start with 20. It's just as simple as that. This value cannot be passed in any other. That's the stateful. Let's try change this. Does this work similar to other language? SQL. Counter plus 5. Now each time I click, it will go plus 5, plus 5. This is simple math. I believe this was in every other language you learn, no matter C, C++, Python. I don't think Java does this, but yeah, I think they do it this in everything. 35, 30, 35, 40, 45, 50. Alright, it's just a simple math, nothing. The counter will be displayed. This is how the values gets displayed. Remember, you have to put a $sign before it. You see that text count $sign, constant size box with unpressed style constant, text increment, elevated button. This is called elevated button. Okay, this is the elevated button. On press increment, the increment, see this, this is this function. Wide increment, this function is called here on pressed. So now we know how a function is called, how a box functions. For example, if you click this, you can mention this here, and this function, you can change it to redirect to some other pages or something, but this is not, let's not mess up anything, okay, because there may be another redirect function, like simple ones. Instead of on pressed, you're calling the function, but you don't have to call, you just simply mention on pressed redirect to this website. I mean, on pressed has to be in the button, elevated button, or maybe what else, what are the buttons exists? Maybe there are different type of buttons. Okay, now wide app, wide main, run app, constant, material app, home, scaffold, body, center, child, counter. This is the counter, the total, the complete class gets called here. All right. You might wonder why stateful widgets state or separate objects in Flutter. These two types of objects have different life cycle. Widgets are temporary objects used to construct a presentation of the application in its current state. State objects, on the other hand, are persistent between calls to build, allowing them to remember information. Like I said, stateless widgets does not store any information, but stateful widgets, whatever the information you store, it stays in there. That's the difference between stateful, stateless. Maybe it has more meanings, but let's see that. The example about accepted user input directly uses the build result method. In more complex application, different part of the widget hierarchy might be responsible for different concerns. For example, one widget might present a complex user interface with the goal of gathering specific information, such as date or location, while another widget uses information to change overall presentation. In Flutter, Change notification flow up widget hierarchy by the way of callbacks, while current state flows down to the stateless widget. The do presentation. The common parent that redirects this flow is the state. Following slide may slightly more complex example applications show how this works. See, we're starting with stateless widget, because here we started with stateful widget, and here we're starting with stateless widget. Counter increment extends stateless widget on pressed. Wait, they have mentioned multiple things here. I'm trying to understand this code. Counter display extends states widget constant. This requires count. Finally, it counts. Okay, they passed an integer on the beginning. Wide callback. Okay. Widget build context return elevated button on pressed increment. Counter, it's the same code, but they call like multiple functions. Same as the one above. Okay, maybe this is something I don't understand because it's the same, but just because the stateful widget is here and this is stateless widget, the wide callback on pressed increment and blah 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 blah, but they may explain this. See, set state. Now the stateless widget become a stateful widget, because in order to contain some storage, you need to change the state. State counter create state counter state. Notice the creation of two new stateless widgets, cleanly separating the concepts. Okay, in order to go from stateless widgets to stateful widget, you have to change the state. but this is kind of a bit confusing, but let's ignore that and see. That is creation of two new stateless widgets, cleanly separating the concerns of displaying the counter display, changing the counter increment, although the net result is the same as the previous example. A separation of responsibility allows a greater complexity to be encapsulated in the individual widgets while maintaining a simplicity in the parent. That is not simplicity. For more information, see stateful widget and set. You know what? Let's look at the references in order to understand it better. Okay, bringing it all together. A widget has a mutable state. A state is the information that can be read synchronously when the widget is built. 2 might change during the lifetime of the widget. It is responsibility of the widget's implementer to ensure that the state is promptly notified when such state changes. Using a stateful widget is the widget that describes part of the user interface by building cancellation of the other widget that describes the user information more concretely. The building process continues recursively until the description of the user interface is fully concrete. A stateful widget are useful when the part of the user interface you're describing can change dynamically. For compositions, that depends only on the configuration information build context. Oh my god, this is a lot of the stateful stateless is a lot. All you need to do is, if you're storing some values, you have to change stateless to stateful. If you're using stateful from the beginning, you don't have to do anything. You can just simply mention the value callback set state, notifying the framework the internal change happen. Whenever you change the internal state of a state, to make the change a function pass to set state. Feature wide increment as sync state set state count. All right. This is something like an error. The memory leak they're mentioning is the value that you input. Okay, I'll say this is really advanced. So not advanced if you're using like multiple pages and multiple functions such as shopping cart or something. Shopping, you put some value in there, and in order for that value to change, I have to do stuff. It's kind of a little bit more, but it's all right. The set state is not something you need to worry in the interfaces for now. Bringing it all together. All right, class product constant require this name final string name. Now let's see, they started with stateless widget. Wait, what? They're still doing that? And they're gonna do a change or something? No? I mean, state set. Let's run and see what it does. Okay, this is like a shopping cart. You click something that will go to the cart, but there isn't much code here. How am I supposed to test it? All right, let's read the code real careful. Require this product, require this cart, require on cart changed. Okay, we're making 3 values mandatory. String, final name, the value is required. Get color context build, the team to reconcile color black 54. This is called black 54. Okay. Theme of context, primary color, text style, get style. If in cart return null, return constants called black 54 or decoration line through. Okay, if not in the cart, return nothing. If in the cart, return this color. A leading circle avatar background color, product name. Where does this, oh, there we go, there's the product. In cart to on cart. How does this change? Am I missing something? This feels like a simple button, but there's no on cart option. Oh, wait. It shows this because it's in the cart is true. If I change in cart to false, it will show nothing. If I'm right, there will be no display. Or it may show nothing's on the cart. It simply displays nothing, but oh, see, it shows different color because it's not in the cart. Wait, where does this end? This is where it ends. Okay. Control C, enter, Control V, enter, Control V. Chips. Stop that error. Change to donuts, cakes, in cart, true. I don't think it will run because it's already saying some error. 6 issues. Let's see the issues. Trying removing one of the argument of correcting name reference to named parameter. Okay. On card was already specified. Guess maybe have to make few child, I guess. Not sure if this is the right thing to do, but You know what? Never mind. I'm not well knowledge to run around with multiple products. Wait, what? Product name 0? So that means if I run with multiple product, I have to mention 1 or 2 or something. Yeah, whatever the case. Now we know if we change 2, it will be additional. The shop algorithm follows a common pattern for stateless widget. It stores the value it receives its instruction in final member variable, which it then uses during its build function. For example, include boolean toggles between two visual appearance. One that uses primary color from current state theme, the other uses gray. That's black 54. When the user taps the list item, the widget doesn't modify its in-cart value directly. Instead, the widget calls the on-cart change function it received from its parent widget. This pattern lets you store state higher in the widget actually, which causes the state to persist for longer periods of time. In the extremes, the state stored on the widget passed to run app persists for the lifetime of application. Okay, now I get it. Even though this may be stateless, but there is a function that calls that value, that is on cart changed, in cart valued. Simple but complicated. It's alright. When the parent receives the on cart changed callback, the parent updates an internal state which triggers the parent to rebuild, create a new instance of a shopping list with a new in-cart value. Although the parent creates a new instance shopping list, when it rebuilds, the operation is cheap because the framework compares newly built widgets with the previously built widgets and applies the only difference to the underlying render objects. Here's an example of mutables. Did they put multiple products here? They didn't. But let's run and see instead of trying to understand the value first. Nice. They have mentioned multiple products, but they mentioned product name here. Wait, is that what I failed to see? But they put products in a bar, but they have only mentioned one product here. So instead of adding multiple like this, I simply put a product tab and call it. Fun part, it's called in the run app, the product names. Ooh, that's a function. If you click, they get Alright. That's a bit of a high end. Now let's look at the codes. Final string name, type, card changed, callback function, products, boolean card. There we go. They call the boolean card. That means true or false. Like the one I did in the earlier. I changed the false to true to false. Then it became like that. Now here they make it on click. class. Let's required. Okay. Final product. Bull in cart. Cart changed. Callback on cart changed. Return in cart. No, shouldn't just do this. If it's returned in cart, you shouldn't just change the color to black. It should be like a ticked or some icon shown next to it, or the end of the line, like here. It's in the cart, a cart's icon. That would be nice, not just get dashed. That doesn't make sense. See the decoration, text decoration, really? Line through, really? If I know some these decorations, I can actually look at them. I can actually look what to do with the text decorations. You know what? Flutter text decoration. Okay, not what I was expecting, but it's okay. Line through, no. Colors black, no. Green. Decoration, text decorations. Bold. Underline. Let's say it will change to green color and it will put an underline instead of lining through it. Say, wait, the icon changed to color. Hold on a second. Return text, return. Huh? Where's the icon? Leading circle outer background, get text gone. Contexts. No, don't get from context, get from the product. Or Get from text style. I mean, this is the icon mentioned, circle avatar, the capital, the leading letter will be become it. Text. D, that's not gonna work out. Get color from text decoration. That also not gonna work. Okay. I don't know where I don't know how to change this. The icon should be green too, but wait, there it is. The context, the color. All right, that's it. The shop list class extended stateful widgets, which means this widget stores mutable state. When the shop list widget is inserted into a tree, the frame calls create state function to create a fresh typically named with leading underscores to indicate that they are private implementation details. When this widget parent labels, the parent creates a new instance of shop list. The framework reuses the shopping list state instance that is already in the tree rather than calling create state again. Okay. All right, make sure to read this. This explains what's happening here. That the stateless widget become a stateful widget, which is a mutable state because the void handle cart changed becomes something that holds the value, because the cart have to hold the value. Okay, when the products gets moved to a shopping cart, that cart have to hold the value of the product. Okay, so that's the only way the product will get moved on to checkout. So that's the main reason they have like changed the state here. Like handle cart changed product in cart pull. When a user changes what's in cart, you need to change the shopping cart instead. That state's called to trigger a rebuild. The framework then calls below, which update visual appearance of the app. Okay, it holds the value, how many in the cart. So we're calling it. This may looks a little bit overwhelming, these codes and the comments, but it's very simple. They have made a stateless widgets from the beginning because it will not hold any value if there's nothing in the cart, but it will hold the value if it's in the cart. Okay. After calling create stateful on the widget, the framework inserts a new state object into the tree when the call's init state. A subclass state can override init state to do work what needs to happen just once. For example, override init state to configure animations or subscribe to platform services. Implementations of init state are required to start by calling super init state. When a state object is no longer needed, the framework calls dispose, and the implementation of this was typically end by calling super dispose. Wow. When you store a value and it no longer needed, a super dispose will be called and end that state will widget value. Keys runtime type. Okay. Is a global key uniquely identifies as child widgets. Global keys must be globally unique across the entire widget hierarchy. Unlike local keys, which needs to be unique among siblings because they are globally unique, a global key can be used to retrieve the states associated with their widget. Alright, that's a good thing to know. Alright guys, now we learned the stateless and stateful widget and in-cart state change and value change increments. If you're gonna store some value, store something, make sure to use stateful widget. If you're just gonna use a interface that does not store any values, just use a stateless widget. But if you're gonna store any values such as let's say number of information numbers or values that changes based on the user, such as address, maybe address call as a value or store value. Anyway, if you want something values like changeable, rememberable, make sure to use stateful widget. If you're not using that, if you're just using an interface or page design, just use stateless widget. Okay, so it won't change anything. Anyway guys, that's the end of introduction to widgets. Thank you for watching. See you all in next video. This video took like 1 hour 10 minutes, and thank you.